Good morning, good afternoon, good evening to everyone. Welcome to our revision sessions in BAS 140, preparations for the sessional exams, and the paper will be written next week on the 2nd of September 2025. Okay, so I have a question there with me. I'm sure we'll be able to go through it together and you should be able to remember something. This is a revision, it means you're not completely blank. So we're just trying to remember one or two things together. So this is an extract of last year's sessional question number 6. So the first question is talking about it's an extract from mathematics of finance. So you should be able to remember some concepts under mathematics of finance and so forth. Okay, let's read it through. So we are being told that a loan of 80,000 is paid off in 4 equal payments at the end of each quarter. So we have a loan, and this loan is equivalent to 80,000. Watch. And then next concept you are being told is paid off in four equal installments. That's what we are being taught. So the loan is paid off in 4 equal installments. Now, there is always a concept I always emphasize on. Mathematics of finance is all about understanding the language which is being used. So that you should be able to tell what kind of information you should be able to use, or what kind of formula you should be able to use when solving it. So now, every time you hear paying off equal installments, that's not to say we are talking about annuities. Every time we hear equal installments are being paid, then we're talking about annuities. So by default, this is an annuity question. Remember that an annuity is a series of equal payments. So once you hear equal payments are being made, now sometimes it's not every time that you are making these equal payments to repay back a loan. Sometimes it can be maybe you are simply making investments. So a question can tell you to say you make equal deposits of maybe 3,000 every year, or maybe 3,000 every month, 3,000 every quarter. That is still an annuity as long as we're talking about equal payments being involved. So once you understand that these are equal payments which are being involved, then by default remember that we're talking about the concept of annuity. So annuity is a series. What is a series? Series is basically a summation. So we're summing up all equal payments put up together to have the full amount you are going to have by the end of a certain period of time. So that is an annuity. Equal series of payments. And then this annuity can be in 2 types. There is what is known as an ordinary annuity. Ordinary annuity, this is in a situation where these equal payments which we are talking about, ordinary annuities, here we're talking about payments made at the end. Now, end of what? It means payments, it can be e.g. it can be end of a month, e.g. it can be end of a quarter, it can be end of a year, and so forth. So as long as those equal payments you are talking about, this person is making them at the end, then we're talking about an ordinary annuity. And then we have another guy who is called an annuity due. Annuity dues, this time around, payments are made at the beginning. Payments are made at the beginning. So these are the 2 different cases of annuities. There's an ordinary annuity and there's an annuity due. So you read a question, you hear equal payments are being made. It means that whatever you make payments in those intervals, if you are making 2,000 kwacha every month, it will be continuously equal amount, which is 2,000 kwacha throughout. It will not change. If you make 2,000 this year, 2,000 the other year, 2,000 and so forth until you complete either your loan or maybe until you complete your investment period. So that is an annuity. That's what it talks about. So even an ordinary annuity and an annuity dues, these two have they have their own different formulas. The formulas are coming about when you want to find the future value of an ordinary annuity. So if these payments are made equally every a certain period of time equally, there is a future value we are going to have after a certain period of time. For example, maybe after 4 years, 10 years, how much are you going to have if the equal payments you're making maybe it's 2,000 kwacha every year? Same applies with annuity dues. If you're making these payments at the beginning of the month, quarter, year, or so forth, how much are you going to have at the end of maybe 5 years? That is an annuity dues. So that is why you have to remember those formulas we gave you on ordinary annuity and annuity dues. So that's a remembrance which you have to understand. When you hear equal payments or equal installments, remember that we're talking about annuity. So that's the first remembering. So now, let's break the question down. This can go. So we are being taught that a loan of 80,000 kwacha is paid off in 4 equal installments. And then at the end of each quarter. So these equal installments are paid at the end. At the end of each quarter. And we understand when you hear the word quarter, how do you even spell quarter? When you hear the word quarter, quarter is simply an indication that we are making these payments every after 3 months. You make a payment, another 3 months you make a payment, another 3 months you make a payment. So now, this loan is paid off in 4 equal installments. So how many times are you going to make sure you clear this loan? You clear it up in 4 equal installments. The first installment will be made in 3 months, the other installment 3 months. So automatically, if it is made every quarter, this can be maybe 3 months. So from maybe 0 to 3 months, from 3 to 6 months, from 6 to 9 months, and from 9 to 12 months. I'm sure you can tell that this is the first installment you can make, the second installment will be made there, the third installment will be made there, and the fourth installment will be made there. And for the fact that the question says it's paid off in 4 equal installments, it means that for this loan to be complete, you've decided to clear it off with only 4 equal installments. And these are the 4 equal installments. So you make a payment here, you make a payment there, you make a payment there, and you make a payment there. So a summation of this is basically a future value you are going to have by the end of this period. Now, how long is it taking you from here to there? How long does it take you? I'm sure you can understand that in years, this is just basically equivalent to what? This is just basically 1 year. Because this is a quarter payment. So we are making payments every after each quarter. 3 months, 3 months, 3 months, 3 months. It means you are going to complete the loan in just basically a year. So now, because we are talking about at the end, you'll be able to tell, say this is an ordinary annuity. So in this question, we are trying to assume that the percentage, this is a loan which you grab today, but when you pay, you're not expected to pay the exact 80,000. There's an interest which is added on top. So it means you're going to pay something more. That's what you understand. So now, in this case, 80,000 is just basically, by definition, 80,000 is our present value. That's by definition. So this 80,000, this is your present value. And when you clear all this loan by these equal installments, these, when you sum them up, there will be more than this 80,000. It means you've paid with interest. That's what we mean. So now, The question says that if it is assumed that an interest of 20%, calculate the amount for each payment. So the interest rate, we have a rate of 20%. We have a rate of 20%. Calculate each amount, each payment, this payment, this payment, this payment, and that payment. We want to calculate this full, each payment. Being since they are equal, talking about if maybe this X is 2,000 quad, even this one will be 2,000, 2,000, and so forth. So what is this equal payment? This is what we want to calculate there. So what do you suggest? You look at your question and you say, okay, this is an ordinary annuity. This is an ordinary annuity, and ordinary annuity because the payments are made at the end. And if payments are made at the end, then it's an ordinary annuity. Now, what do you have which is going to help you come up with the payment which you are making every quarter? So you have the present value. It is the one which is going to help you. So now, there are two formulas for annuity, ordinary annuities. There is the future value. Future value is equal to the interval payments you are making, which you are going to be PMT, multiplied by 1 plus I power, or let me write it in terms of a compounded. So 1 plus R over N, NT minus 1 over R over N. So this is the general formula when you're finding the future value. But in this question, do you have the future value? You don't have the future value. What you have is the 80,000, which is the actual loan at the present right now. So it means this formula will not work out because you want to find the PMT, which is the payments in intervals. So what do? You will have to use the what? The present value formula. So what does the present value formula state? The present value formula, let me just delete this part. My body is small, so the present value formula becomes PV to be equals to PMT multiplied by, so what's the difference? Future value starts with PMT multiplied by 1 plus R over N, but the present value starts with the 1 minus 1 plus R over N power negative NT over R over N. So the power here is negative NT, but the power here is positive NT. So we are using the present value formula. This is the future value formula. So depending with what you have, in this case you understand that you have a present value, meaning the present value formula which is at work. Here we don't have the future value. If we had the future value, for example, the loan 80,000 is due in 1 year, it means this is a future value for 1 year. Then we could have used this. But it does not say that 80,000 is due in 1 year. It just says this is a loan. Meaning that we are assuming that this loan is the one which is being gotten right now at the present. So this is a loan at the present. If the statement was 80,000 due in 1 year, then 80,000 could have been the future value in 1 year to come. So that's the concept which you have to understand. But in this case, it is the present value because there is no due date there. Now we want to find the payment, so we are using the present value formula. So what are we going to replace here? PMT, which we are looking for, present value is 80,000. So we're going to have 80,000 to be equals to the PMT which we are looking for, multiplied by 1 minus, open bracket, 1 plus. So this R is equals to 20%, and this 20% is equals to 0.2. Now we said that R over N is basically the number of conversions, remember, according to compound interest. So in this case, N is basically how many times are we compounding this in a year. For the fact that we are paying at the end of each quarter, then we are bringing in the conversions of 4 times in a year. So it means I'm going to have 0.2 divided by 4 as my conversion because of the quarter. If this was simply saying it is paid at the end of each month, I'm looking at the conversion to be 12 times in a year. So if it was paid each month, the end could have been 12. If it was paid each semi-annually, the conversion could have been 2. So that's the concept you have to understand. Multiplied by NT, N is multiplied by 4. T is basically 1 year because 4 quarters in a year makes it 1 year. Something like that. And this is divided by 0.2 over 4. So that we can have 80,000 to be equals to PMT multiplied by, now a calculator should work. So we have 0.2 divided by 4, which is this guy. 0.2 divided by 4, I have 0.05. 0.05 plus a 1, that is just basically what? So I'm going to have 1 minus, open bracket, 1.05 to the power 4 times 1 is negative 4 over 0. 0.05 close. So this is what I'm going to have 1. So I'm going to have 0.05 for that. So I'm sure you can punch this on a calculator. It's just a matter of you using your calculator now. So it means I'm going to have 1.05 to the power negative 4. I'm going to have this amount, then 1 minus my answer. I'm going to have that amount divided by 0.05. I'm going to have that amount. So I'm having something like 80,000 to be equals to PMT, which I'm looking for. This, when you punch everything, this, we are going to have something which is approximately 3.545951, something like that. So that for me to find the PMT, we will just basically divide both sides by 3.545951, even the other side 3.545951, so that this goes, and my PMT now will now be equals to 80,000 divided by this. So 8123 divided by my answer, and the answer is now going to be equal to 22,560.95. This is your payment made every after a quarter. So the payments made every after a quarter will be 22,560 quarters. That's the first answer on question A, which says find the amount of each payment. So each payment in 4 equal installments, which is paid after a quarter, after 3 months, you are going to be making payment of 22,560.95. That's what you are going to have every after 3 months. So question number A has been handled. Now the question continues. I'll delete this part. The question continues to say, so question number A, here we have each payment is basically 22,560.95 watts. That's the each payment you're going to have. Question number 2 is just something which is very much direct and straightforward. What is the present value of the loan? And it is just even 1 mark. As you can see, we already said that the present value is the loan itself, which I grab at the present right now. So the present value here, that's basically equals to what? 80,000 watts. Just a 1 mark without stressing. But if this loan was 80,000 due in 5 years, it is the future value for 5 years. So that's what you have to understand, the future value for 5 years. So with that concept, automatically this will no longer be the present value, but it will be future value for 5 years. But for the fact that I just said this is a loan of 80,000, means it's the amount we have right now at the present. And then question 3 says find the total amount of interest paid. The total amount of interest paid. So interest is what is topped up on top of the what? Principal, or on top of the present value. So what is going to be added on top? That's the question. What is going to be added on top of the present value? So if this is my present value, we are now going to top up something on top. That is the interest. How do I find the interest? The interest is just basically equals to the future value minus the present value. So the future value is how much you are paying in total. Now if you are making these equal payments 4 times each, automatically this is just direct straightforward. First payment will be this, the other payment will be the same thing, the other payment for 4 times. So it means the future value which I'm going to have, it will just basically this coming out 4 times. So it means my interest will not be equal to future value, will be equal to the equal payments 2,560 multiplied by 95. This is multiplied by what? By 4. Why am I multiplying by 4? Because the question says it's paid up in 4 equal installments. So if each installment is basically this guy multiplied by 4, I'll have the total future value. The answer for this will subtract the present value, which is 80,000. Then the difference is basically the interest. So we have 22,560.95 multiplied by 4. So we are going to have a value of 90,243.8. This is your future value. Subtract 80,000. So when we subtract the 80,000, we are going to have the interest paid, which will be 10,243.8 as the interest paid. As simple as that. So that is how you basically will handle question 6A under ordinary annuity. Annuity, as long as you hear the concept of equal payments, remember annuity. Then from there, understand, are the payments made at the beginning, or the payments made at the end? If it is at the end, ordinary annuity. At the beginning, annuity dues. And remember all those formulas on ordinary and annuity dues. Okay, let's go to B. This can go. Let's go to B. B says find the coefficient. We are looking for the coefficient. We are looking for the coefficient. How do you spell coefficient? C-O-E-F-F. Find the coefficient of, this is A, this is power 6 and B power 5 in the expansion. In the expansion 3A minus 2B power 11. Find the coefficient. Now the question comes in, what is a coefficient? What is a coefficient? A coefficient is just basically a constant which is attached to a variable. a constant which is attached to a variable. I'm sure in grade 2, there were concepts like you have 3x squared plus 2x minus 1. And then the criteria to say find what is the coefficient of x squared. So in this expression which you have to understand that x is a variable, 3 is a constant, 2 is a constant, negative 1 is also a constant. So it's talking about a coefficient. We're just talking about the value or the constant value attached to a variable, implying that 3 is a coefficient of x squared. Again, at the same time, we can say 2 is a coefficient of x. So, what are we just talking about? The value, constant values attached to a variable. So even if you are looking for a constant, a coefficient, ask yourself, what coefficient am I looking for? We are looking for the coefficient of x, coefficient of x squared, coefficient of x power 3, coefficient of that, and so forth. So that's the concept you have to understand. So that was in grade 2, which we are trying to remember, recall. So now the question says coefficient of a power 6 and b power 5. A and b are variables. So the first task is you expanding this. That is when you'll be able to see where a power 6 is and b power 5 is. So by default, a power 6 and b power 5 will be the same. I'm sure we understand the binomial aspect. If you didn't understand binomial theorem, then you have to go back to your lesson on binomial theorem, where we said expanding this is more like your first term and this is more like your second term. So implying that the first term 3a is basically decreasing power starting from 11. So 3a will have the power of 11 in the first term, and it will continue to decrease until it reaches 3a power 0. I'm sure you remember the concept under by now. So the first task is you expanding this. That is the first task. I'm sure that in fact that is the long cut method. You can expand this. After expanding, locate where a power 6 and b power 5 is, and then grab the coefficient attached to it. As simple as that. But that is the long process, because if you look at this guy, this is h big power. So for you to start expanding until the last term, obviously you will stress. So what can you do? You can use the rth term formula. Remember we said that T r is basically equals to n r minus 1 a power n minus r minus 1 b power r minus 1. So this is the rth term. So a is represented for the first term, b is represented for the second term. So 3a is the first term, negative 2b is the second term. So for me to have this guy, if this is coming from the a is coming from the first term, implying that comparing this with that, this can mean that n minus r minus 1 should be equal to a 6, according to what we've been given there. And this is the second term. Also comparing with b, which is the second term, the power for the second term is r minus 1, which should be equal to what? A 5. So now, what does this all mean? We're trying to look at the value of what? Maybe find the value of r, because n is basically the power. So if n is basically the power, it means that this is 11 minus r minus 1 to be equal to a 6, implying that this would be what? 11 break inside negative 1 plus 1 equals to 6, and this would be a 12 minus r equals to 6, and this will be 12 minus 6 is equals to r, and 12 minus 6 is basically what? 6. Am I correct? So our rth value is basically 6. So in actual sense, if you found your value to be r to be 6, then we are looking for what? The 6th term. So since r is 6, we are looking for the 6th term, and this 6th term will now be equals to n, which is 11 combination 6. A is the first term, which is 3a power 11 minus 6, because it is n minus this. B, which is the second term, negative 2b, negative 2b power r minus 1, which is this, and this is a 6, and this is basically our what? Hey, sorry. r is 6, so it means in the bracket here we are going to have r minus 1, which is 6 minus 1, which is a 5, 11 minus that, which is a 5, and this is negative 2b or 5, implying that our 6th term will be equals to the 11 combination 5, 3a power 11 minus a 5, which is a 6, negative 2b power 5. And if you can see, this is where this is coming from. So where a is power 6 and b is power 5. So if that is the case, so now we're simply saying that for me to find the coefficient, I have to find where this term is. Or we are trying to use the upper aspect of what? The rth term formula. And the rth term formula is equals to n combination r minus 1, a power n minus r minus 1, and b power r minus 1. This r minus 1 here, it is the power for b. This r minus 1 subtracts the n to have the power for a. As simple as that. So with that concept, we'll be able to find the rth term. So we want to look for the value of r, which is giving us this particular value, or this particular term. So we had to compare this to that. Since a is found in the first term, implying that n minus r minus 1 should be equal to this 6. This b is coming from the second term. This implies that r minus 1 should be equal to what? 5. Then we solve for what? We'll solve for r there. That is why solving for r, I think this one was even the same case. So you take 5 to the other side, becomes r equals to 6. As simple as the same as this one. R is equals to 6. So it means we are looking for the 6th term. Replacing everything in the formula, n is 11, r is now 6, 6 minus 1 is 5, a is 3a, 3a power 11, which is the n, minus 5, which I'm going to have a 6, negative 2b power 6 minus 1, which is a 5. Now we can now expand and solve. Then you ask yourself to say, okay, what is the 11 combination 5? 11 combination 5 is just basically giving you, so I'm going to have T6 to equals to 462, that is 11 combination 5. Here I have 3 power 6. So 3 power 6, I'm going to have 729. A power 6, it is still a power 6. Negative 2 power 5. 2 power 5 is basically 32. It means I'm going to have negative 32. And b is as usual b power 5. So this is means that I'm going to multiply 462 multiplied by 729 multiplied by negative 32. So I'm going to have 462 multiplied by 729 multiplied by negative 32, and I'm going to have our T6 to be equals to 10,777. Am I correct? Yeah. So I'm going to have 10,777, and this is 10,777. 10,777,000. This is a comma. 5, 3, 6. Yeah. And then we have a power 6 and b power 5. That's the value. Implying that the coefficient, it is this number attached to this guy. A power 6, b power 5. It is this number we are going to have here. That is our value. So this value is obtained from 11 combination 5 multiplied by 3 power 6 multiplied by negative 2 power 5. That's the number which is attached to a power 6. So 11 combination 5 is basically 462, and 462 multiplied by 3 power 6 is basically that, and then multiplied by negative 2 power 5. That actually this is a negative, so it means even here to be the outcome will be negative that. So this is what we are going to have. So the coefficient, it is this number here, as simple as that. We are okay. And then the next part, that is question C. We can look at the next part, question C. So this was under the binomial aspect. Sometimes if you don't want to use this approach, you feel like expanding is the easiest. You can expand and automatically you are going to have a certain term which is going to come up. On the 6th term, you are going to have this guy. And then the coefficient you're just talking about is this guy. The question says what is the coefficient. So therefore the coefficient of this is negative 10, 7, 7, 7, 5, 3, 6. This is the coefficient which they wanted. We are okay. Let's go to question number 6. Question number C. Question number C says, question number C says a beauty shop which sells cosmetics. A beauty shop which sells cosmetics has a demand function and a total cost function given by the equation. So we have the demand function P is equals to 240 minus a 10Q, and then it has a total cost of 120 minus 8Q. That's a demand function and a total cost function. And then question 1 says write down the equation for the total revenue and total profit. So total revenue, remember total revenue is just basically price multiplied by quantity. What is your price? Price is given by this guy. So it means that my total revenue is equals to 240 minus 10Q multiplied by the quantity Q. This is the price. This is the demand function is basically the amount which the buyers are willing to give out. So it means that they are coming with this amount, paying us as the sellers. So this is the price coming from the payment from the sellers as a demand function. So multiplied by the quantity, how many they've bought, Q. So this equation is going to give us the total revenue, implying that my total revenue will now be equal to, if I multiply throughout, I'm going to have negative 10Q squared plus 240Q. That is the total revenue function. And what is the profit function? Profit is just basically equals to total revenue minus what? Total cost. So profit will be equals to total revenue is 120. Actually, total revenue it is negative 10Q squared plus 240Q minus total cost, which is 120 minus 8Q. So that my profit is now going to be equals to 10Q squared plus 240Q we can break through negative 120 plus 8q. Like terms together, I'm going to have 240 plus this, implying that I'm going to have my profit to be equal to negative 10q squared. This plus this, it will be equal to 248q minus a 120. This will be my profit function. So, so, and then from there, we have, after solving the first question, we're being told to say use the second derivative to find or to calculate the number of items which must be sold to maximize profits. This is where the application of derivatives comes in. Remember, under the application of derivatives, we mentioned that the maximum or the maximum point is found by, or the maximum or minimum point is found by using the second derivative. So it means for me to know how much units, we're talking about Q units, how much Q units is going to make me maximize my profit, I have to find the second derivative of the profit function and then use the second derivative test by saying that the second derivative at that particular point of Q, if it is less than 0, then it is a maximum point, and if it is greater than 0, then it is a minimum value. So this was our A, total revenue and total cost. So in our B, we are looking at the value for the profit. Since profit function is negative 10q squared plus 248q minus 120. This is our profit function. So it's the one we are going to use. And then we thought we can be able to know our units needed. Okay, so how many units? We are going to find the first derivative. So it means we're talking about d dq. So the pi there is representing the symbol for profit. So d dq of this function, it means I'm going to differentiate with respect to q first time. So it means that the power drops down, the power decreases by 1. So I'm using the power rule to differentiate this guy. Our respect, or maybe our variable, is basically the q. So we're differentiating all these terms with respect to q. So what am I going to have? This 2 drops down, becomes times negative 10. I'm going to have negative 20 q. The 2 decreases by 1 to be power 1 plus, here it is 1. 1 drops down, becomes 248. Q 1 minus 1, it is the power 0. It means I'm going to have this. This is the first derivative which I'm going to have. We're okay? And then from there, we are simply saying that find the second derivative. The second derivative, what am I going to have? We are going to have d double prime, when I say d this of, this is means I'm trying to differentiate this twice. So the first time it drops to this, then the second time we're going to differentiate again with respect to q. This is a constant. Differentiating this guy, it will drop. It means that I'm going to have the value for what? Negative 20 here as my second derivative. We are okay? So it means that for me to have the so if we have d that, so for me to have, this is my second derivative function, this is my first derivative. Now remember, we said that when finding the maximum point, first we have to find more like the turning point. So the first point we are going to use here is by finding the value of q in this particular context. So keep this as your first derivative and use the first derivative to solve the value of q when this is equal to 0. So we are going to use this to solve for q. when d dq is equals to 0. So when d dq is equals to 0, taking about this to be equals to this means negative 20q plus 248 should be equals to 0. So solving for q there, this goes to the other side, becomes negative 20q to be equals to negative 248 over negative 20 over negative 20, and the value of q becomes what? So I'm going to have 248 divided by 20, having a 12.4 as the value of q. So this q which we have here, the question is it true that this is a maximum point or a minimum value? This is the only value of q we have. So the question says use a second derivative test. So we're simply saying if this is a second derivative of this function, after differentiating it twice, we have this guy. Then if d over d2q at 12.4 is less than 0, then it's a maximum. But if it's greater than 0, then it's a minimum. That's what we know. So the question says use the second derivative to calculate the number of the items which must be used to maximize profit. So it means we are looking at for the point which can maximize our profit. So if this q is less than the second derivative, is less than 0 in the second derivative function when you put in q to be 12.5. Now, this second derivative has no q here. This is more like a constant function. So whatsoever q you insert here, the value will still be negative 20. And negative 20 is basically less than a what? A 0. So therefore, the number of items which you need to have here, q, should be equals to what? 12.4 units needed to maximize profit. So this is what is needed to maximize profit. So just running through, what are we simply saying? Number one, differentiate your profit function. After that, or maybe we could have simply said before you differentiate, find the value of q. So you have to solve the value of q. So after you differentiate first, then you have to solve for q when d pi dq is equal to 0. We'll solve for q. Then test this q. If this q is a maximum or if this q is a minimum. That's what we mean. So differentiate once. In the first derivative, solve for q when this is equal to 0. After that, test this guy. Is this a maximum or is it a minimum point? How do you test it? By finding the second derivative. Second derivative, the expression you're going to have, insert q in there. And if the answer is less than a 0, then it's a maximum. If the answer is greater than 0, then it's a minimum. So that's how you'll be able to handle it. So the maximum units needed is basically what? 12.4 units which are needed. We are okay? Now let's look at the last part, question D. Let's look at the last part, question D. So question D says differentiate. So what am I differentiating? F of x is equal to the root of x multiplied by the natural log of 2x. Want to differentiate that function? So the concept of differentiation, you have to be able to remember all those methods. So now, if you look at f of x, you understand that f of x is a product of two functions. They can be this first function and they can be this other function. So what is happening? You can let this to be more like your u, and you can let this to be more like your v. This is a function of x. This is also a function of x, but these two are multiplying together. So it means if we differentiate f of x if differentiated becomes f prime of x. So f of prime of x will be equals to, differentiate the first function, it means you are going to have u prime multiplied by v, plus differentiate the second function, that is v prime multiplied by u. That's the product rule. This is from the product rule. So product rule works out, eventually you see a product of two functions making up f of x. So after that, what is u prime? U prime is differentiating this. So you can say u prime is equals to, now look at this, u is equals to the root of x, which means it can be written as 1 over 2. So it means if you are looking for u prime, the 1 over 2 drops down, x and 1 minus 1 over 2, implying that you are talking about 1 over 2 x or negative 1 over 2. And this can be written as what? This negative can be put in the non-can, in the denominator, so that we can have 1 over 2 root x. So it means that if you differentiate u, you are going to have your u prime to be equals to this guy. You go to v prime. V prime is equal to, so I'm going to have v prime. This is a natural log. How do you differentiate a natural log? Differentiate the inside here. Differentiating 2x, you just remain with the 2 over the actual itself, which is 2x. So this and this can go, so that we can have v prime to be equals to 1 over x. Am I correct? So differentiating the inside, the numerator, over the actual inside, which is 2x. So if you differentiate 2x, will remain with the 2 over the actual inside, 2x will be that. So that when we replace number in the function f prime of x, this is now going to be equals to u prime, it is 1 over 2 root x, multiplied by v, v is the natural log of 2x, plus v prime is 1 over x, multiplied by u, which is the root of x. Then simplify. If we simplify, what do we have? This is just basically the same as f prime of x to be equal to, this time that it is the natural log of 2x over 2 root x plus the root of x over x. Something like that. And then from there, what can I do? Is it in a simple version? Even just like that, it is a derivative. The rest is just basically you simplifying it if you can to lost terms. Yeah, otherwise just like that it is still okay. Because if you factor out root of that, but it still makes sense. Just like that. So this is your f prime of x. As simple as that. So with that done, I'm sure you'll be able to remember one or two things concerning what you've revised today. Thank you very much, and see you in our next video. God bless and all the best in your preparations.